And welcome back as we go ahead and jump in to discuss variables and memory, specifically looking at how those different things that we've been creating are stored within a computer's memory address. So let's first by discussing variables. Variables of a class type and variables of a primitive type behave pretty differently actually in Java. Variables of a primitive type name their values in a straightforward way. So for example, if it's n an int, then n can contain the value of type int, such as 42. If we had v, which is a variable of a class type, then v does not directly contain an object of its class. Instead, when we have that variable, v, it's actually naming an object that contains the memory address of where the object is located in memory. And this is why if we try to, for example, do a system print line, we will get some gibberish stuff instead of, necessarily like, what's the name, what's the age, things like that. Because remember, a class is really more of a container. So this is getting us to talk a little bit about some computer architecture stuff, particularly looking at two things, which is secondary and main memory. A computer has two forms of memory that are, of course, called secondary and main. The secondary memory is what is used to hold files for more or less permanent storage. So this is like your hard drive, your SSD, your NVMe. These are things that are there for when your computer shuts down. It's going to record that and it'll still be there. The main memory, or oftentimes we refer to things like RAM or something just computer memory, is what the computer uses when it's running a program. So this is of course just temporary memory. So when you lose your power or you end that execution, all of the stuff that was in memory is no longer there. Values that are stored in a program's variables are kept in the main memory. Now, to kind of give us a little bit of understanding of how class type variables are used, to learn a few details about how program variables are represented in main memory, let's assume that each variable in a program is of some primitive type such as int, double, or char. Alright, so the first thing we need to understand is a byte address. Main memory, or the memory of your computer, consists of a long list of numbered locations called bytes, each containing 8 bits, that is, 8 0 or 1 digits. The number that identifies a byte is its address. A data item, such as a number or letter, can be stored in one of these bytes, and the address of the byte is then used to find the data item when it's needed. Well, this byte thing is really tying into what we commonly refer to as a memory location. Most data types have values that require more than 1 byte of storage. When a data type requires more than 1 byte of storage, several adjacent bytes are often used to hold that data item. In this case, the entire chunk of memory that holds the data item is still referred to as a memory location. The address of the first of the bytes that make up this memory location is used as the address for the larger memory location. Thus, as a kind of practical matter, you can think of the computer's main memory as a long list of memory locations of different varying sizes. So, before we go ahead and look at this deeper, let's ask ourselves a question. Why 8 bits? Well, a byte is a memory location that can hold 8 bits. And you might ask yourself, well, what's so special about 8? Why are we using 8 and why not something like 10? Because, 10 is a number we're familiar with. Well, there's two primary reasons why 8 is special. The first is that 8 is the power of 2. 8 is 2 to the power of 3. And since computers use bits, which are just representation of 0 and 1, powers of 2 really kind of lend themselves to be much more convenient than powers of 10. Secondly, it turns out that 7 bits are required to code a single character of the ASCII character set. So having 8 bits, or 1 byte, is the smallest power of 2 that will hold a single character. Now, here's an example just to kind of help put some context to some of the stuff that we talked about. So we're going to start looking at variables in memory and how they're used. So here I have a variable 1, or var1. And you can see it has a 3-byte location starting at address 0. So that means it's shaded in here with the red. Byte 0, byte 1, and byte 2 are taking up that address. var2 is a 2-byte location, which means it requires 2 bytes of memory, and it starts at address 3. Variable 3 has a 1-byte location at address 5. So this would be, for example, like a Boolean value, which are simply just true or false. And then lastly, we have var4, which is another 3-byte location. You notice it starts at address 6. Now, one thing to keep in mind in this example, you'll notice that, of course, it does start at address 0. This is a very common thing that when we start talking about memory locations, we don't have things start necessarily at 1. We have them start at 0. So just like how we have seen things with strings, for example, we talk about the position of a string, and we're going to see later when we talk about arrays, having these lists like this start at position 0 is a very common thing you'll see in computer science. But this should help give you a nice, good visual example of how some of this is used. Obviously, if you have different data types, they're going to use different lengths here. Like I said, the Boolean, that's probably 1. If you remember, we talked about ints having 1 length, doubles having a predetermined length, so on and so forth. So just something to keep in mind to help you give a nice visual representation of how we represent some of these variables here in memory.